to do that.
I didn't think that through.
Even overlay.
All right, so we're going to take a look at differential equations and how they wind up in word problems. And the first step really in looking at this is looking at the clues in English that tip us off that mathematically we're talking about a differential equation. All right, so Mike, read for us.
Bacteria in a lab culture grow in such a way that the instantaneous rate of change of bacteria is directly proportional to the number of bacteria present.
All right, that sentence is really, really important, and it says a lot. So, can you read it again?
Yeah. Bacteria in a lab culture grow in such a way that the instantaneous rate of change...
All right, hold on. Instantaneous rate of change of bacteria. What's that screaming at you? Try again.
Derivative.
The derivative. Right. The rate of change.
Instantaneous.
Right. Rate of change.
Directly proportional.
So, hold on. I'm not there yet. So the rate of change of bacteria, I'm going to call that dB dt. That's the bacteria changing with respect to time. Is that okay?
Yeah.
All right, keep going, Mike. Stop. What? Is. All right, equals. All right, next two words.
Directly proportional.
All right, directly proportional means from pre-calc.
Proportion.
Nice.
It means something equals k times. There's a constant of proportionality. So I need some constant of proportionality. So is equal and directly proportional is that k value. To what?
The number of bacteria present.
Okay, the number that are present, which is b. That's the number of bacteria. So that's that English that translates into that differential equation. I'm going to be totally honest with you. You are going to get really good at seeing those particular words. And you want to be on the lookout for this. The rate, and whenever you see rate, that's going to be derivative, is equals, and then they're going to be, I would say 7 out of 10 of the problems you're going to see at first is going to be proportional to the amount. So k times b, or k times whatever the function is. There are going to be some times when it might say is proportional to the square root of the amount, or is inversely proportional to, right? K over whatever. So, yeah, k times 1 over whatever, right? So, we're going to focus a little bit on just this terminology, is directly proportional to the number present. But after that is, we can say it in a bunch of ways that gets translated into different mathematical relationships. We've actually seen this differential equation probably 2 or 3 times now, to the point where some of you might be able to tell me what the answer is without even solving it. Desiree? C e to the kt. That's what it's going to end up being. That's totally what it's going to end up being. So, we're going to do, I think Chris, he's not here today, wanted to ask me the question and I wasn't willing to say yes. And if you ask me on Monday, I might be willing to say yes. You still have to solve this differential equation. Okay? Chris wanted to know if we can get to the point where we don't have to do the solution, we can just write the answer because we've seen it so many times. And I will get to the point where I'll say yes to that, unless it says, like, show all your work or solve the differential equation. But it's really important to understand that that solution that Desiree started and then Christina and Julia finished, that only works with when it says the rate is directly proportional to the amount. Only works in that instant. So, all right, let's do this. I'm going to get 1 over b dB is equal to k dt. Integrate both sides. The 1 over b, natural log of the absolute value of b, plus c, but I'm actually going to save that over on this side, kt plus c. This translates to the absolute value of b equals e to the kt plus c, which after a little bit of algebra actually ends up being c e to the kt.
You said it's okay if we just skip that absolute value for that.
No.
I mean, that middle step.
Yeah. Now we can take away the absolute value signs, and I'll reiterate, many calculus students just know that you can take them away somewhere. It'd be really nice for, at some point, like when you're in calc next year, to tell like your professor when he or she asks, like, oh, you can drop the absolute value signs now because C can be positive or negative. All right?
You already know that right now.
I know, but I'm saying, like, don't be like all the others out there who are just like, oh, you just drop them because that's exactly. And that's exactly what we said we were going to get for our answer. So we just solved that differential equation. I don't even know if we were supposed to. Mike, what's the question asking us?
Suppose initially there are 5 million bacteria. 3 hours later, the number is grown to 7 million.
This is good because this is an exponential equation, right?
I think so. What?
Bacteria population 1 full day after this.
Okay, so it's asking me questions about the bacteria's population, and Christina says, well, this is good because this equation actually tells me what the population of bacteria is. Initially, there are 5 million bacteria. That's actually screaming at you.
A, B, C.
C or B?
C. Initial. C.
Yes, 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 yes. Yes, 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 yes.
Why?
Right, aren't we in Spanish class?
P is always the initial amount. It's like the equals, whatever P equals P not P.
I thought P was initial amount.
Because then it'll be like X and 3 equals C.
So 5 equals C, e to the k, initially time is 0, so that e to the 0 is, e to the 0 is, e to the 0 is 1, so C equals 5. That's what you told me, that's fine. So we know B is equal to 5 times e to the kt. Our equation isn't finished yet, though.
Who's not far?
Yeah,
Population
what?
1 million. Or not even.
No,
3 hours.
3 hours. 3 hours. The time is 3, and you do 7.
Okay, so
you can get what B is by like setting the 2.
what do we need to? We're trying to find k value. All right, so
No, never do.
actually, that's an interesting question.
Well, it never says any other.
So if we use 3, when we answer the question 1 full day, can we plug in 1 for time for this 1 full day?
No, you can put 24.
Exactly. So if you want to be in hours now, it just means you have to be in hours for the whole problem. All right, so Desiree is saying, like, look, if you're going to use 3, make sure you understand we're in hours. All right, 7 divided by 5 equals e to the 3k. ln of 7/5 equals 3k. K equals ln of 7/5 divided by 3. And I wonder what that's about.
0.112.
Keep going. Give me one more decimal.
1.
Okay.
5.
Oh. And you have 2 choices. Leave it like ln 7/5 over 3. Approximate it to at least 4 decimals. With an exponential, you really want to go to 4. But better yet, store that value. Like once you get it, just store it as like alpha k. And use the stored value. All right, so I think we have an equation now. B is equal to 5 e to the ln of 7/5 over 3 times t. And I want to find out how many after a day. What do I plug in where? 24 for t. And what about when it asks when is the population a billion?
Yeah, got it.
Set it equal to a billion.
Yeah, what?
Well, it can't be a billion. It has to be like 10. What was this? 1,000? Well, we said
Yeah,
5 was
all right.
1,000, so it has to be.
What does 5 represent? 5 represents 5 million.
Wait, no, 5 is 1,000. Oh, it's million. 1,000? So it has to be 10, doesn't it? 1.
Well,
We're
so
100.
10 would be 10 million. 100 would be 100 million. So Desiree, I think you said 1,000 would be the same as a billion, right? 1,000 million is a billion. So in order to solve that part, you'd set it equal to 1,000 and solve. Whoops, I don't know why that... Hold on. I will. Huh. Are you sure?
What are you plugging for T? 24?
For the first.
Well, there are two questions. One's asking, what's the population 24 hours later?
And then what's
And
the other one?
when is it a billion?
So you keep taking.
Mm-hmm. And I actually, to be honest, am not inclined to solve either of those because I think you can do that.
Because we have calculator.
And you have algebra. You could do that algebraically. You could. Julia?
Yeah.
Didn't you have a hand up? No. For real?
Mm-hmm.
Oh. All right.
For B from before, did you get 73.87? Yeah, 8 million.
Yeah.
All right, Julia.
Yeah.
26. Let's read.
When water-cooled nuclear power plant is operated and
Is in operation, I guess? I'm missing a word or something. Or operational. Sorry about that.
oxygen in the water is transmuted to nitrogen-17. After the reactor is shut down, the radiation from this nitrogen-17 decreases in such a way that the rate of change in the radiation level is directly proportional to the radiation level.
All right. There it is. That was important. So the rate of change of the level.
Equals the DLDT.
All right. Is directly proportional to the radiation level. Is that all right?
Yeah.
Now, like I said, you're going to get to a point where you're going to ask, like, all right, I've done that. I know what the answer is going to be. If we were to solve this, what would the equation for L be?
L equals C, E, T, E, LT, or KT.
Yep. Now, you're still on the hook for solving it, though, even though we just didn't. Right? And on Monday, you can ask me again. And maybe I'll say yes.
No, you can't plug a number in it.
Well, actually, isn't this now a pre-calculus question?
I don't remember.
All right, go ahead. Read for us, Julia.
Suppose that when the reactor is first shut down, the radiation level was 3 times 10 to the 17 units.
All right, so what's that they're telling us? Whoops. What information did they just tell us? Yeah, Mike says that's what the initial units or radiation level is. So 3 times 10 to the 17th is C. All right, Julia.
After 60 seconds, the level is dropped 5.6 times 10 to the 13 units.
All right, so they've given us another piece of information.
That's 1 minute.
So what do you want to do? Do you want to be in seconds or minutes? I don't really care.
It says at the end, it says minutes, compartment. So it's 5 minutes after each reaction.
Oh, so you want to stay in minutes?
Yeah.
Okay, that's fine. So we know that the level is 5.6 times 10 to the 13th when T is 1. So I think that's enough information to find out what K is. Do you know how to do that on your calculator?
Yes.
And algebraic? No.
There are 2 ways of doing it on your calculator. And algebraically. Yeah, you're right. I mean, I guess while this gets going. No, that won't go in the background. Interesting. Like it won't go behind. So, algebraically, we're taking 5.6 times 10 to the 13th, dividing by 3 times 10 to the 17th, and then taking the natural log of that. And just to show you on your calculator, if you wanted to, you're going to do the natural log of up top. What was it? And you know, well, you could do time. You can do times 10 to the 13th, but you can also do second comma, right? And you say 13th? Is that what you said? Yeah. Yeah, it's going to be an exponential decay. And so that's what your K value is. Alright? So actually, that's a very large K value, which tells you that the radiation level is dropping very rapidly. And if you think about that, it's going from something times 10 to the 17th to something times 10 to the 13th. That's a pretty big drop. That's an order of magnitude of 10 to the 4th. So it's like 10, 100, like it's 100,000 times less in just a minute. Now, it says 5 minutes have to go by for it to be safe, or what does it say? Oh, will it be safe? Will it have dropped to this many units in 5 minutes? I don't know. Should we do it?
No.
Let's see if it's safe. I'm interested. So all you really need to do is, we know what C is, and we're asking our question, in 5 minutes, will it be safe? So I just need to plug 5 into that. So I have my equation is, and find out what time that is. Yeah, sure. So there's C, here's E raised to the, I'm going to do my second answer, because that's the answer I just got, times 5, because that's what time is, because we're in minutes, because you told me to stay in minutes. And I get 0.067.
Can you write out like what you did on the calculator? Can you like write it? Like what did you just multiply by 5 what we had before? Like I don't mean like with the numbers, like.
So this is the equation I plugged into the function. The function is C e to the kt.
Okay.
And I knew what k was from here, so that's actually what I wrote. C e to the kt.
Oh,
And
it seems 5. Okay.
so let's see if I can do this in a more clever fashion.
0.67
Uh-oh. Alright. So here we go. This is C. There's E. The answer was K. And that's T. I'm just pleased with myself if you're not that excited. Okay. And we found that it's 0.067. Well, guess what? 7 times 10 to the negative third is 0.007. So it doesn't look like we're safe yet to go in. So don't go in after 5 minutes. You have to wait a little longer. I don't want you getting radiation poisoning or something.